For do now number 2, we want to state if the two triangles are congruent, and if so, why. So remember, we have 5 ways to prove that triangles are congruent. We can do side, 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 angle, side, angle, side, angle, side, angle, angle, side, and hypotenuse, leg. Those are the only 5 ways that there are. Okay, you can never have side, side, angle, or angle, angle, side. Okay, so keep that in mind. So these are no, the others are yes. Okay, so for part A, again, I have this side is congruent to this side is congruent to this side, and then this angle is congruent to this angle. So I have a side, an angle, and a side. And we just need to make sure that that's the included angle. So how do I know that? If I trace the two sides that are congruent, it needs to form angle A. And if I do, it does form angle A. So this is side, angle, side. For part B, I have 2 right triangles. And again, if I look directly opposite the right angle, I have a measure of 6 in the first triangle. And in that second triangle, also when I look directly across, I have a measure of 6, which means that AC is congruent to PR. Then if I look down at BC, I see that BC is 3. And when I look over at the other triangle, I see that QR is also 3. So that means that BC is congruent to QR. Okay, now again, be careful here. This is an angle, this is a side, and this is a side. You cannot prove triangles congruent by angle, side, side. That's this. Okay, this is a right triangle. You have the hypotenuse of that triangle and you have the leg of that triangle. I know it's a right triangle because again, that right marker, that right angle marker in the corner. So these 2 triangles are congruent by hypotenuse, leg. In C, I have this side congruent to this side and this side congruent to that side. There's only one other thing from this picture that I can tell without being told, and that's I have a pair of vertical angles that are going to be congruent. So again, I have a side, I have an angle, and I have a side, and I just want to make sure that if I trace my 2 congruent sides in the one triangle, that it forms that congruent angle, and it does. So again, you have angle, side, angle. For part D, have an angle, you have a pair of sides, and you have another pair of sides. Can't do that way. So these are not congruent, or you can't prove them congruent. So for 3.3, we're going to talk more about triangle proofs, and we're going to talk about how to prove a mathematical theory. So inside of our statements and reasons columns, we're going to talk about first what you can have on the reason side. So if you have sides that are congruent, here's 4 ways that you can tell that they're going to be congruent and that you'll use inside of that statements and reasons. One reason that sides can be congruent if it's a given statement. Another reason, if you're told that something is a midpoint would break a line segment into 2 congruent segments. So you could have 2 sides that are congruent because of a midpoint. You could also have a line bisector. So again, if it bisects the line segment with another line, that would again cut it into 2 congruent segments. Again, you could use that as a reason for why sides are congruent. Okay, and they can also be congruent because of the reflexive property. So again, if they share a common side, that would be the reflexive property. Okay, reasons that angles can be congruent. Again, just like sides, you could be given that the angles are congruent. And again, like you could with the sides, but this time up here you were given a line bisector. Down here you have to be told it's an angle bisector. If it's an angle bisector, it's going to cut into 2 congruent angles. So you can use definition of an angle bisector inside of a proof. Another reason angles could be congruent is if they're right angles. Again, every single right angle has 90 degrees in it, and that means that all right angles are going to be congruent. Vertical angles. If you have a pair of vertical angles are going to be congruent. And then we also have some reasons if you have parallel lines. So things from parallel lines that we learned back in chapter 2. If you have corresponding angles would be congruent. You could also have alternate exterior angles that are congruent. I don't know why I didn't type these in. You could also have alternate interior angles that are congruent because of parallel lines. Okay, and the other thing that you can have not part of parallel lines, okay, I'm just going to pull it out here just so you know. You can also have an angle that overlaps, so you could also have an angle that's congruent by the reflexive property as well. So we're going to use all of them inside our proofs today. Okay, so the first thing that we're going to do is we're just going to mark off the things in the picture that are given and that are congruent, and then decide why they're going to be congruent in the end if they are congruent. So my given, I'm told that AC is congruent to DF. So I'll put 1/ through AC, 1 through DF. That takes care of that given. I'm also told that angle A is congruent to angle D. Done. And then angle B is congruent to angle E. So again, I'm going to put 2 hash marks through that to show that that's a different angle than angle A. So now I need to decide if I can prove these 2 triangles congruent. Again, I have an angle, and a side there. An angle, side is a way to prove them congruent. Right there, angle, side. For number 2, you're given line ABC. Doesn't really help you, but the fact that, again, our congruent statements will. Angle A is congruent to angle C. Angle 1 is congruent to angle 2. So again, the second pair of congruent angles, we'll do 2 lines. If you had a third pair of angles that were congruent, you use 3. And B is the midpoint of AC. So again, if B is the midpoint of AC, that means that the midpoint is going to cut that line segment into 2 congruent segments, which means that AB is going to be congruent to BC. And again, I have an angle, a side, and an angle. And again, to be angle, side, angle, that side that you're marking congruent has to touch both those congruent angles, and it does. So this is going to be angle, side, angle, which is going to be that choice there. And then for my third one, I have AB is congruent to AD. So again, I'll mark AB congruent to AD. And then BC, that's my second pair of sides. So I'm going to use 2 hash marks as congruent to DC. And again, I want to see if I can prove these congruent. I only have 2 sides right now. Again, there's only one other thing that I can assume from this picture. They share this side. So CA is going to be equal to CA. We usually put an X through it when it's reflexive. Okay, so that means that you have a side, and a side, and side, side is one of your options there. For 4, I have AD is congruent to BC, and then I have DE is congruent to CE, and I want to prove that the 2 triangles are congruent. Hey, do not assume anything. Do not assume that this is a right angle here. You were not told that. You don't have any vertical angles here. There's nothing else in this picture that you have. You do not have a pair of vertical angles. So the only thing that you have is 2 sides, and 2 sides is not enough to prove the triangle's congruent. So the answer is none. For the next one, for your given, you have line DCA and line ECB. Not going to help you at all here. Only your congruent statements will, or definition of perpendicular lines, things of that nature. So I have DC is congruent to AC, and DE is congruent to AB. Okay, and that's all I have from my givens. And again, now I want to know if I can prove the triangle's congruent. So right now I have 2 sides and I don't have anything else marked off. But in this picture, there is one other thing that I can get from the picture. And that's this pair of vertical angles here, which is going to be an angle. So I have angle, side, side. Angle, side, side is not a way to prove triangles congruent. So the answer there is none. For 6, I have RS is perpendicular to ST. Okay, so RS is perpendicular to ST means that this is going to be a right angle there. So that's going to take care of that given. And then I have UV is perpendicular to TU, which means that that's going to be a right angle there. So right now I have 2 right triangles, 2 things off the bat. Maybe I can do hypotenuse leg, or again, those right angles can end up being congruent. Let's see what else we have. We have RT and VT. Okay, and now I want to know if I have enough information to prove the triangle's congruent. Okay, you have just the hypotenuse here, you don't have another leg, or you have an angle and the hypotenuse. Either way, it is not enough information. So those true triangles cannot be proved congruent. So now let's see what this would look like inside of a proof. So we want to fill in the missing reasons for each proof. Okay, and again, the first thing that's going to go inside every single proof is always the given. So if you look at everything that's written here, notice that that's everything in step 1. So why do we know that that's true? Because it was given to us. Okay, and again, I'm going to start marking my picture with things that I know from my given, and then see what happens with step 2. CD bisects AB. Again, CD cuts AB. So AB is what's getting cut. So that means that AE is going to be congruent to BE, which look right here. That's there. And then also if I look at the second one, AB is going to cut CD. So CD is getting cut into 2 congruent pieces, which means this piece is going to be congruent to that piece. And that's right there. Okay, so why did that happen? That word right there, the definition of a bisector. Okay, the next thing that I have in statement number 3 is I have a pair of angles here. So angle AEC, which is that angle there, and angle BED is that angle there. So now I need to say why those 2 angles are congruent. Those are vertical angles. So that is exactly what we're going to write for a reason. So vertical angles are congruent. And now I have the triangle ACE is congruent to triangle BDE. And again, that's because I have a side, an angle, and another side. So those 2 triangles are congruent by side, angle, side. Okay, and our last one here, I have AD bisects angle BAC, and AD is perpendicular to BC, and we want to prove triangle ADB is congruent to triangle ADC. Okay, again, notice in statement number 1, that's all your givens from up here. So the reason that those things are true is because they were given. Okay, and now the next thing that I have is that angle BAD, this angle here, is congruent to CAD, which is this angle there. That's going to come from this step right here. I was told that AD bisects that angle. It cuts that angle into 2 congruent pieces. So that's the definition of an angle bisector. Okay, definition of an angle bisector. The next thing that I have is angle ADB and angle ADC are right angles. Those 2 angles are here and here. And how do I know that those are right angles? Look back up to here. Those 2 things are perpendicular. Perpendicular lines intersect to form right angles. So this is going to be definition of perpendicular lines. Okay, and now for the next step, now I had the fact that they were right angles in step 3, and now in step 4, I'm telling you that this angle is congruent to that angle. So why are they congruent? Each of those angles has 90 degrees in it. Okay, right angles are congruent. Okay, any 2 right angles are going to be congruent. This is always the easiest one to recognize. AD is congruent to AD. Again, anything that's congruent to itself is the reflexive property. And again, I have an angle, a side, and an angle there. And again, that side is connecting your 2 congruent angles. So those 2 triangles are congruent because of angle, side, angle. Okay, please don't forget that you are going to have a quiz after the next section. So after section 3-4.